Hello everyone, my name is Eric and today we'll be talking about dividing and dealing with negative exponents. Before we do that, I'll just go over some basic laws of exponents and how they work. The first of which is that a number to a certain power plus the same number to the same power again equals 2 of that number to the same power. And the same with subtracting, it's the same concept. The second is that a number to a certain power times another number to a different power equals the same number, but then you add the exponents together. And the third is that a number to a certain power and then that to a certain power is the number, and then you multiply the exponents together to get the last power. The fourth is that a number to a certain power divided by a number to another power is the same as that number, and then you subtract the exponents. And the fifth one and final one is that anything to the 0th power is 1 no matter what, unless a is equals. Dividing exponents. When dividing terms with like bases that have exponents, you subtract the exponents and don't do anything to the bases. If there are coefficients present other than 1, then you have to divide the coefficients. One example would be a to the 20th power divided by a to the 5th power. So the first thing you look for is if there's a coefficient, and there isn't one, so we'll just go on. Next you subtract the exponents, which is 20 minus 5, and your answer is a to the 15th power. Let's do another one. 2a to the 17th power divided by a to the 4th power. Alright. So again, you'll check for any coefficients. There are 2 and 1 here, so you divide them to get 2. And then so you subtract the exponents at the top, 17 minus 4. So the answer is 2a to the 13th power. A third one is 5a to the 38th divided by 2a to the 23rd power. First you'll check for coefficients again, and there are 5 and 2. You divide them to get 5 halves. Next you'll subtract the exponents 38 and 23, and the answer is 5 halves a to the 15th power. Alright, so 156a to the 245th power divided by 12a to the 161st. Now, check for coefficients. They are 156 and 12. You divide them to get 13. Next you subtract the exponents, 245 and 181. And then your answer is 13a to the 84th power. Alright, this one is a little bit more complex. It looks more complex, but the steps are the same, so it's really simple. Check for the coefficients. There are 8,948 and 4. You divide them to get 2,237. Next you'll subtract the exponents, which are 7,375 and 3,656, and the answer is 2,237a to the 3,719th power. So as you can see, it gets more complex, but if you follow the basic rules, it's still pretty easy. Alright, negative exponents. When dealing with negative exponents, any base in the numerator with a negative exponent needs to be moved to the denominator, and any base in the denominator with a negative exponent needs to be moved to the numerator, so you just switch them over to the different side of the equation. This only, well, top and bottom, not side to side. This only applies to the base unless there are parentheses grouping them. So an example, a to the negative 5th power, well, first move the term to the denominator, and that's it. The answer is 1 over a to the 5th. Alright, example 2. 4a to the negative 7th. First you'll move the term with a negative exponent to the denominator, but you won't move the 4 because only the a has a negative exponent, so the answer is 4 over a to the 7th. Example 3. 5a to the negative 3rd. First you'll move the term with a negative exponent to the denominator, and the answer is 1 over 5a to the 3rd, because the parentheses groups them, so it affects both of them. Example 4. 2 times 7a to the negative 4th. First you'll move the term with a negative exponent to the denominator, So the answer is 2 over 7a to the 4th, because the exponent only affects the 7a and not the 2, because it's not in the parentheses. The 5th, 48 times 6a to the negative 56th. First you'll move the term with the negative exponent to the denominator, like always, and the answer is 48 over 6a to the 56th. But be careful, because you can't simplify here, because the 48 is not to the 56th power just like the 6, so that wouldn't work. Alright, so now we'll try to combine both skills together and see what happens. First example, a to the negative 7th over a to the 3rd. First you'll check for coefficients, and there aren't any here. Next you'll move the term with the negative exponent to the bottom, and then you'll add the exponents together, because they're next to each other. And the first answer is 1 over a to the 10th. Alright, 4 over 2a to the negative 5th. First you'll move the a to the negative 5th to the top, since it has a negative exponent. Then you will divide the two coefficients, and this should end up giving you an answer of 2a to the 5th over 1, which simplifies to 2a to the 5th. Example 3. 6a to the negative 3rd divided by 3a to the negative 5th. First you'll switch both the negative terms, because they're both negative. Next you'll divide the coefficients, and you'll get 2 as your answer. Finally subtract the exponents, because we're dividing, and the answer is 2a squared. Example 4, 64a to the negative 54th divided by 16a to the negative 27th. First you will switch both the negative terms, next you'll divide the coefficients to get 4, and then you'll subtract the exponents because we're dividing, and finally you'll have to move the negative term to the bottom again since it's negative again, and the answer is 4 over a to the 27th. Example 5. 20a squared a to the negative 25th divided by 5. First you'll switch the negative term, and then you will divide the coefficients, and then you'll subtract the exponents because we're dividing again, and then finally again you will move the negative term to the bottom, and your answer should be 4 over a to the 13th power. Thank you for watching, and I hope this helped you.